we are entering the quantum computing.
Okay.
So basically, if I understand quantum computing, we know we started initially analog computers,
Right.
and from where the black screens and all those things we used to manage, and then we moved to the digital screens. Now it became, the digital screen became a mobile screen today,
Right.
and everything touch screen and all that we have seen. Now what is this quantum computing? Because what we see in India, we have, I don't know how many people, how many Indians are actually aware. In fact, the QPI AI is an Indian company started by an Indian entrepreneur. His name sounds like a, Chedi Buddy, the Nagendra Nagaraja.
Exactly.
A very our own Bangalorean.
Our own Bangalorean.
Bangalorean. And we feel so proud when we listen to him and the kind of work they have done already.
Right.
In fact, India's first 25 qubit supercomputing quantum computer was already launched.
Yes.
And it is also called as QPI AI Indas is the
And
name.
it's also funded by Government of India.
Absolutely. So there is a huge mission,
Huge
the
government
quantum
backing
mission.
also, yes.
So what do you have your views on this? Because this actually makes me, feel so good from within that, because we buy computers from IBM and HP and all this kind of, hardware.
Right.
So are we looking at manufacturing computers in India with chips in India? What exactly is this?
That already started happening. Now you can see there is a huge drive led by the Government of India in semiconductor manufacturing, and the almost 1 lakh crore is being invested in semiconductor manufacturing. So a lot of like Foxconn and many other I think Taiwan-based semiconductor manufacturers are setting up factories, especially in Tata Tech has been set up in Assam, Guwahati, and Noida, Gurgaon also, the Dixon Technologies, they are one of the pioneers in semiconductor manufacturing. So huge investments are happening. So as far as computer is concerned, already we started doing that. But quantum computing is a new it's not new. It's another phenomena which is going to change the world forever. So it's like by leaps and bounds. So the conventional computing is very different from conventional computing. So normally, in traditional computing, we use zeros and ones.
Binary.
Bits. So basically binaries. So either in the form of zeros or ones, right? So in quantum computing, it can use zeros or ones or the combination of both. So the state of both it can combine. So that actually makes it possible to explore multiple functions parallelly. So normally what we achieve in traditional computing in sequential manner, there it can be done parallelly. The same task can be done parallelly. I mean, multiple computation path can be explored simultaneously at the same time. Whereas in current computing system, it is not possible. Everything happens in sequence. Though, we have the processors, we use multiple processors to split the task, and it happens so fast, though it happens in sequence, but that is called time slicing in the concept of multi-threading. So it happens so fast that it gives you an impression that it is happening simultaneously, but it is not. It's all in a sequence. Whereas in quantum computing, everything can be, millions of computations can happen simultaneously at the same time. Not at all sequence. So imagine.
So basically, you are saying it can change the world for a common man.
Yes. So for example, any new chemical reactions, it can explore multiple combinations at the same time and give you the output much faster than.
So that means in medicine and in healthcare,
in genetic research, in healthcare, agriculture, weather forecasting, you name it. In every field, it's going to bring about a huge change, and that will change the world forever. So not only that, in communication, telecom sector, so even there is a concept called, I think research is going on, called quantum entanglement, right? So basically two quantum particles, once they are entangled, so any change happens in one particle, at the same time the state of the other particle changes, same changes.
So it's a karma theory, like we say in spirituality.
So imagine you have two quantum particles which are entangled between each other across two multiple galaxies. So it can communicate instantly, even how far ever it is in a
So
different
somewhere somebody
galaxy.
sitting in Mercury or
Exactly.
some
So
aliens.
all that sci-fi thing that we have seen probably is going to be
But what I'm interested is if it can change the way we can cure cancer, we can treat
absolutely.
the health.
And it can do new innovations, let's say on physics, some certain theories or like certain mathematical problems which are yet to be solved. Probably quantum computing will be able to, with the help of AI, quantum computing and AI, probably new theories will be discovered, or new
No, sir,
problems.
the beauty is that we are already there in
Yeah, we
India.
are already there.
So my question is, how does India's QPI AI compare to quantum computing giants? There are big ones like IBM's and these kind
IBM
of.
has been working on this. They are pioneers in this, and because they started very early, I think since early 80s, 90s, they started working. So of course they have that early mover advantage. We are late to start, but I think we are already there, and we are making great progress, and we'll be able to catch up very soon, probably in next decade or so.
So because I have some data in front of me which says IBM's Osprey chip, it has 433 qubits
Qubits.
in 2023
Right.
and it's targeting 1000 plus qubits. And Google Systems has
They are about
72 to 133
yeah.
qubits with quantum supremacy demonstrations. And then our own Indian QPI AI launched India's first 25 qubit superconducting
Right.
quantum computer.
And we are also targeting, I think, by next 2030.
So what I have the data from the web is that QPI roadmap is about 128 NISQ qubits in 2 years, and probably you will understand all this, and
Right.
100 plus logical qubits by 2030.
Yeah. So I think we'll catch up very soon. I have no doubt about that.
So another 4-5 years, you think there is a possibility that the way we use our computers or the way we calculate things, and you were talking about in our casual conversations a couple of days back, you were saying today the security, the security in the banking, that whatever 64.
So that is going to be a big risk. I think all this current day encryptions, normally they're all 128-bit encryptions that normally used. So in quantum computing, it can be hacked in just matter of in fraction of seconds, where probably a current computer system may take 100 years. Same can be achieved in fraction of seconds. So I think the security also, I think we need to evolve our security system also in tandem with the capability of quantum computing.
So can it be a kind of an advantage to a country? Suppose if you develop the first capability of quantum computing in real times, and you can actually take over the supremacy in terms of technology, and where others will have to buy technology from you.
Yes.
I mean, I'm just talking about more like a fiction, but is it a possibility that if I develop in India, suppose if we develop quantum computing faster, and we are able to actually kind of whatever you're talking about, the security, I mean, in fact, that's why there's a lot of news that I read that all the agencies, the government agencies, particularly like the federal agencies, the CBI here or whatever they invest, they are very closely monitoring the developments in terms of, because that's their job to protect their country's data as well as people. And it's a financial transaction today. Whatever money I have in my bank account, it's only my password. Now, if somebody is taking out my password and my money goes to some other account or some other institution, of course, talking hypothetically, so that can be the task of the quantum computing.
That's the negative side of it, or the challenge you call it.
Challenge.
So I think probably we'll find a solution for that as well with the help of quantum computing itself.
But what we should actually take note of things is, this will not happen just like that without government intervention. And we have seen the India's quantum computing investment strategy by the government. Because what we see is the National Quantum Mission. What I have in my system is about 6,000 crores.
Yeah, that's the same reason government also taking a deep interest, because they know the risk involved of being late in the game. So that's why I think there is such a huge push from the government as well.
So what are the commercial implications of quantum computing advancement? If I have to look at it, for example, let's say HSBC achieved about 34% improvement in bond trading prediction using IBM's quantum processor. So there can be a commercial advantages when you increase your computing capabilities,
Right.
because you manage large amount of data predicting interest rate fluctuations and various things, especially in banking and finance. The computing is the most underlying thing to be able to be effective. So how do you see this?
As I said, right, I think the level of parallelization that it will achieve, it will be in order of
Multiple times it can multifold.
magnitude, basically. So, which a traditional computer can't do. So that is what will help, because the combinations, number of combinations it can generate and validate at the same time. So that will, the exploring ability will be much far superior than what we have today. So that is going to help in not only this, in every field, especially in discoveries. Right, in medical research, probably we'll find cures for most of the diseases in next 10 years once the quantum computing becomes.
And just bringing another fact, Sumanji, I'm recollecting from one of the interviews of Mr. Nagendra Nagaraja, who is founder of this QPI AI, a Bangalorean. He was telling that on November 1st, that is our Kannada Rajyotsava, though we celebrate the Karnataka, whole of Karnataka we celebrate as the yearly day for the Karnataka. On that day, he says, we are ready to launch the next, I think, I don't know whether it is 75 qubit or something. So they are calling that as a Cavary, I think.
Right.
So it's a huge moment of pride for us that someone from Karnataka has been doing this great job, and it's going to actually make huge value additions to the country as a whole. Because today war is not fought in the battleground, it is fought in the labs.
In the labs.
So, what do you say about this? It's a great moment for all of us living in Bangalore.
I think it's a great moment, and it's a proud thing for us that somebody from Karnataka is doing it, sitting in Bangalore, where we are also sitting. So I think, and also driving the whole quantum mission, leapfrogging the whole quantum mission, and it's inspiring the next generation to come forward and contribute to quantum computing, right? So I think also the the government is also making sure that they introduce the kind of syllabus in the education curriculum that basically trains our next generation to be quantum computing ready. So I think that is also a big push that is happening from the government end. So I think altogether we are in a great shape. We are not far behind. That's what I can say.